mode where we're talking about moving passengers and freight by rail. That is overseen by the Federal Railroad Administration, and there's a lot going on. You've probably heard a lot about high-speed rail. Well, the person we're having to talk to you today is going to focus on a number of other activities in the Federal Railroad Administration. We're delighted to have Melissa Shurland, who is the Program Manager for Rail, Energy, Environment, and Engine, or E3 technology, under the Federal Railroad Administration. Melissa?
Thank you, Mr. Gee. Good morning, ladies and gentlemen. My name is Melissa Shurland, and I am a program manager at FRA, which is a Federal Railroad Administration Office of Research and Development. Today, my presentation will look at how engineers at FRA help move the nation's rail network into the future. I will give you an overview of FRA's mission, our research and development program methodology, examples of our R&D projects, and what engineers at the FRA do. Our main concern is safety. FRA develops and enforces comprehensive safety regulations for freight and passenger rail transportation. These standards are the minimum standards for operating rail transportation in our nation. We also administer financial assistance loan and grants program so that railroads can improve and rehabilitate their infrastructure. And this is needed, as you saw with the highway question of making sure that our roads are healthy. Our railroads needs to be healthy as well. FRA also oversees Amtrak's budget and finances, as well as their intercity passenger rail program. FRA is also tasked with implementing government programs and initiatives such as the high-speed intercity passenger rail program, the Positive Train Control Implementation Program, PTC. As Mr. Valdez mentioned, PTC is a form of CBTC, computer-based train control, as well as our National Rail Plan. As I said, our research program is primarily safety-focused and covers both freight and passenger operation. So how do we go ahead in solving our research issues? This slide shows the approach that we take for many research programs. First, we identify the problems from our accident database and other sources. We develop hypotheses about this problem and perform tests and simulations to assess the baseline situation. The results from such tests allows us to refine our hypotheses. Furthermore, we adjust our baseline and develop new technology to make train transportation safer. I'm going to show you what our baseline problem looks like. This is a baseline testing of our tank cars that operate on the railroad. This test simulates a currently designed tank car being impacted by the coupler of another rail car in a derailment situation. As you can see, the coupler actually punctures the tank car. And this would be a tank car that would be carrying things such as chlorine gas, which is very hazardous. And this is one of the problems that we are protecting against with our research. With our R&D effort, we have developed new advanced design for rail tank cars. Here's a testing of the new and improved tank car. And once again, the impactor is the same coupler system, symbolizing a coupler from another rail car. And with this new design, we get no puncture, which is what we want, ensuring safe rail transportation. Other than equipment issues, we also have to maintain our tracks and substructures. As long as the equipment are designed safely, if we have bad tracks, we will run into problems as well. Some of the problems that we see in the railroads are wide gauges, worn rails, broken rails as well. We also have a issue of lateral misalignments, which we call sun kinks. And these issues pop up in the summertime when the temperature of the rail elevates above a certain point. And they happen very rapidly. A situation like this will cause derailment on the railroads, injuring passengers, damaging freight, as well as nearby residents can be harmed depending on the goods that are being transported. So FRA R&D is focused on addressing some of these problems. So how do we address these issues? We have developed what we call a track research car that traverse our rails and detect defects within the rails themselves, the substructure, as well as the components that hold them together. What you see here are 3 types of the car we have. Our rail joint bar inspection system detects cracks in the joint bars, which are devices that connect the ends of 2 rails. These systems prevent derailments. So where do we do our testing? Our testing is done at our Transportation Technology Center located out in Pueblo, Colorado. This center is used by our Office of R&D, other government agencies such as FTA and the Transportation Security Agency, TSA, as well as the railroad industry. We also have a simulator that can be used by locomotive engineers to learn how to move the train. These simulators tracks the performance of the human vehicle interface as well as the various components that are located in the lab. I will show an example of the baseline of our current passenger train system and the research that we're doing to improve that system. The top frame shows the conventionally designed rail car impacting a locomotive. And what you see is loss of occupant space as well as override. This is a dangerous situation. The bottom frame shows a newly designed technology called crash energy management that controls the crash of a rail vehicle. It impacts a much heavier vehicle and maintains its place on the rail as well as preserve the space where the passengers will ride out the crash. The bottom frame is a type of technology that FRA is promoting for future rail car designs. So what does an engineer at FRA do? Our mechanical and civil engineers develop technologies such as onboard and wayside equipment health monitoring systems that will tell you whether or not the equipment on the trains are at the point where they need to be replaced or repaired. We developed the crash energy management system you saw on the passenger train. We also look at the track and the substructure to make sure that they're safe as possible. Our electrical and electronics engineer, we look at positive train control systems such as CBTC, trespasses detection and prevention system to ensure that people don't lose their lives while on the railroads. The human factor engineers look at how employees of railroad, how working in the environment affect their job performance. They look at stuff as the fatigue of the hours of service, the human-machine interface, as well as organizational behaviors and dynamics. Human factors developed what we call the CTIL, which is a CAP Technology Integration Laboratory that assess performance of locomotive engineers. So it was my hope today that I leave you with a sense of what an engineer at FRA does and pique your interest about engineering in general. Thank you.